We've seen on the basic level how to add actors, how to manipulate actors, so how to move them around and so forth. We have looked at the begin play and the tick functions on a basic level as well. So at this point we want to kind of move on and we want to look at how we can spawn actors from our C++ code. So in the previous video we talked about how we can destroy actors, right? So it only makes sense that we now learn about how we can go about spawning our actors. In many cases you'll go and do this in the level blueprint. So I'll click on this and open the level blueprint here. And so we are actually going to start this discussion by creating our own level script. So if you go to the class settings, you can see you have a parent class. And so of course this means you can change the parent class. That means we can have some functionality defined in C++, and then we can simply go and extend this in blueprints. What it also means is that we can, so once we have functionality for our level, we can start to clean some of that up and put that maybe in C++, especially where you use the tick function. You would want to go and clean that up and then add that instead in C++. Alright, so let's just take a look at how we can do this. First I'll go and I'll create a new C++ class. I'll click this show all classes and I'll search for level script and I'll choose level script actor. In the tooltip here it actually explains more or less what this does. This has the a prefix, meaning that this also derives from actor, but these instances are hidden actors that exist within a level and they can execute level while logic, so basically operating on specific actor instances within a level. That is basically what you do in level blueprints anyway, right? The main difference here is that we want to have in some cases some base functionality already exposed in C++, and then we can simply inherit from that and then build on that using Blueprint Visual Scripting. So I'm going to select level script actor, click next. I'll just call this test level script actor, or you can leave it at my level script actor. It doesn't really matter in this case. I'll just click create class. So as you can see, the class is fairly clean. We do not have the begin play or the tick function or even the constructor. So we have to go and add those here. You can see this is the constructor. It doesn't return anything. It simply has the name of this actor. Remember the A. Okay, this will get added automatically. You need to add that. You cannot simply use the text that you added. You again have to add that A in front as well. Also note that IntelliSense might take some time. It might take some time for you to catch up with all of this. I'll do quick actions and then I'll go and create the definition of that. Test level script actor begin play. You can just type it out like this if you want. I often do that, actually. I just type it out. But to save yourself some time, you can just again go and right click on it, quick actions, and then you can create the definition. We want to do the super begin play. So in other words, it will execute the parent functionality that is contained within begin play as well. We've talked about this previously, but I just wanted to make sure that you go ahead and include this super begin play in here. I'll do a quick build here just to make sure that this actually compiles properly before I move on. Jump back to the .cpp file here, and in the begin play, I'll type out get world. If you hover over this, you can see it is a getter for the cached world pointer, which doesn't tell us much. But basically this will return null if the actor is not actually spawned in a level. So this is a top-down approach. This is a uWorld, and that is basically a top-level object or a level. So if this is in the level, then we can go and do the spawn actor function. Now the spawn actor function will of course spawn our actors. So we can also specify the type right here. So for right now, I'll simply specify a actor. You can see we have something called the U class, which is basically an object class, and we have a transform. So basically, what is it that we want to spawn, right? An instance of what? We want to create an object of some actor. Well, we already have these chairs, right? Or that chair class. So let's just spawn a chair. Now there are a few ways of doing this. So before moving on, I'd like you to note again that instead of following along with me, like step by step typing out exactly what I do, instead go and watch the lesson. So go and try this after actually finishing the video, okay, and the lecture. And the main reason for that is as I go through and explain a couple of things throughout the video, I'm going to go back, I'm going to change things, I'm going to make mistakes deliberately to show you like some of the problems that you might have had by doing this, by yourself. And I'll show you like the reason why certain things work the way they do. And also the next section will start with a U class, but later on in the video, I'm actually going to change this declaration slightly to something else that is more type safe. So with that out of the way, let's just continue here. This again will be a chair, so I'll just call it my chair. And then in the constructor, we can go and assign that. Now, of course, this does not know about our chair yet, so we have to go and include the header. So back in the constructor. Now from here, what we can do is we can call a function called static class. So the static class function is a bit weirdly named. The name is not all that descriptive really, but basically what this does is it returns an object of that class. And you can see we actually get these squigglies here. No operator matches these operands. So this is why I mentioned that you should watch the video first, because I'm going to explain some of these things as we go along. If I hover over this static class thing here, you can see it is a static function. UClass again is simply an object class. It also derives from UObject, which is why it has that U prefix. But you can see it has that asterisk. Okay, so that's a pointer that we have to go and set right here. If I go back, that squiggly should go away, as you can see. So that is fine. And that again is in the header where we declare this my chair of type UClass. I simply make that a pointer now. And so for that first parameter, I'll go and pass in my chair. Okay, so what I'm going to do is I'll create something called fTransform and I'll call that the spawn location. Previously we talked about location and rotation, right? We talked about vectors and we talked about rotators. And I mentioned that I'll talk about the transform a bit later. And so this transform basically contains the location, rotation, and scale information. Now I'll change this later. For right now, what I'm going to do is I'm simply going to pass that in here. And that'll be zeroed out by default. Okay, just to get going so I can show you in Unreal Engine what this will do now. So again, this will go from the top down. It will get a reference to the current level basically. If this actor is not in the level, then this will simply return null. Otherwise, it's going to go and spawn whatever actor we specify right here, in this case, the type of A actor, my chair, and then spawn location. If I go to 1 here, you can see you have UClass, and then we have the transform. Okay, so basically that's all I'm doing. I'm passing it or the type that I want to spawn, and then I'm giving it a location. Now what you also want to do is you want to specify this as a U property. And I'm going to set that to edit defaults only. And this should work fine. I'm actually going to close the editor for right now, and I'll build and run that. Okay, again in the level blueprint. and in the class settings, I'll click on this drop down, and then I'll go to test level script actor. Then in the class defaults, now we did not give that a category, so this will be under test level script actor. Now you can see we have this huge list. And in upcoming sections I'll show you how you can avoid this. But we can search now. And I want the chair blueprint, because that is set up the way we want already, with the static mesh and all of that stuff set up. So I'll compile and save, and you can see so far everything works fine. And now if I click play, this should spawn an actor in the world. We have this other functionality in the chair, this add impulse. We also have this set lifespan. Just for right now, you can go and take that out if you want, but I'm actually going to leave this in. And instead what I'm going to do is, back in the test level script actor, in the .cpp file in the begin play, where we have the F transform, this is not a pointer, so again we use the dot operator here. And as you can see, we can set the location, we can set the rotation, and so on. So just to save some time, I'll declare this F actor right here. So I'm just setting the initial location. Again, I'm passing that into here. This now is where it will spawn that actor. So this again, where we declare this myChair uClass, we can now go and specify in the details panel specifically what object it is that we want to go and spawn. Alright, so with this line added, I'll go and build again. For right now, I'll actually just delete this. Move around a bit. Just make sure my chair is set here again. You can see the variable name is myChair, just as we have set that in the header. So that is myChair. As soon as we click play, that will spawn at the location that we specified, but then it will add that impulse that is specified right here. Okay, add impulse, and it should also actually get destroyed because I have not removed that function. You can see it gets destroyed after a few seconds as well. Now we can still go and add functionality from begin play, from event tick, and so on, and go and add variables in here. This is its own blueprint. It simply has that test level actor script as its parent. In the constructor, I have this initialized again, right? So if I go back to the class defaults, so I can go and revert this, and you'll see that will actually revert to chair. So I'll just compile and save that actually. And if I go and play this now, you can see that we have this chair instance spawned at the location 00100. But it does not have any representation in the world. You can see it gets destroyed, and that's because we have that set up to be destroyed. And you can actually see we get an error because simulate physics is not enabled by default. So what does this mean? Well, if I open up chair.cpp, you can see that chair component is a static mesh component. So what we can do is we can set simulate physics to true by default. You can do that. Or what you can simply do is you can go and comment these things out. But let's just build here just for fun and see what happens. Okay, now if I click play, that should work fine. I'll select chair. That'll get destroyed. But the point is, it is in our world here. It spawns at 00100. You can also go and give it some representation if you want to do that. And it actually won't go and apply that add impulse when the game starts, you'll see this thing doesn't move. Play, you can select it again. And the main reason is we don't have a static mesh, it doesn't have any physics to work with. You can see as soon as I select one, that drops down to the floor. But the point is this is not very useful, so that is why I go and select the blueprint one, this chair blueprint, because it's already set up for us properly. Compile and save that. Now if I click simulate, you can see that works fine. So in some cases you might want to have your static mesh component to have some static mesh assigned by default. Otherwise you'll have to go and create a blueprint and then assign one from there, right? Now that is very useful because we have that menu, we can choose a specific asset in that way, and it's not hard-coded. But if you want to hard-code it, you can do that. And this is useful for simple assets that you just want to spawn. So in this case, we just want to spawn a chair and then add an impulse to that, right? If you want to do more complex assets, then you can always do a blueprint, create a blueprint class inheriting from that. And if you have that set as visible anywhere as you have it here, so this class, your static mesh component, then you can go and select the specific static mesh that you want from the menu. Okay, so in this section, I want to introduce you to a helper for when you want to assign a default static mesh to your actor, or to your static mesh component, that is. Okay, so this is more or less what it'll look like. So we have the constructor helpers, and that is basically a struct. And so right here, I'll right click on this and I'll pick definition. This is a struct, so it's like a container of containers basically. We have this fObject finder, it's a template, which actually inherits from this class. So in C++, of course, a struct can inherit from a class. And then what it does is you can construct it. As you can see, I'm passing in that text macro again to pass in that string. So it has this object to find, which here is assigned to this path name fstring. And then here it uses this here to assign or to initialize that object. We don't have to know exactly like how all of this stuff works, but you can see it passes in that path name now, and it assigns the object in that way. So this again is just a helper. This is a template, so we want to specify the type. Don't get confused here with the components. We already have a component. We want a static mesh. You have skeletal meshes as well. For right now, we want to focus on the static mesh. Okay, so how do we now get, again, that, let's just pick definition again, this object to find, which will eventually get used to initialize that object? Well, we can do that actually from Unreal Editor. So I'm going to open up the Unreal Editor here, and I'll actually just open up this chair blueprint. And with that component selected, we assigned this static mesh in the blueprint. So this is not assigned by default, or should I say in C++. This is now the class defaults for this blueprint class. But we now want to set the default static mesh for this particular chair component in C++. So I'm going to browse to that asset in the content browser. You can always just go and find, in the folder structure here, go and search for the particular asset that you want. That's just one way of getting like what you already have assigned. Okay. Then I can go and right click on that, and you have this copy reference, which will basically copy the path for that asset to the clipboard. So copy reference. Then I'll simply go and paste that in here. You can see it starts off with the object type. So in this case, again, static mesh. Then again, the rest of the path for that specific chair. Again, make sure you have your parentheses and everything set up correctly. And you'll see sometimes you have the single quotes here as well and stuff like that. That's fine. Leave it just as is, as you copied it in. So I copied that whole thing from the clipboard between these opening and closing double quotes. So that is now our string. And that will basically construct this object, and now we can use it to access that object that it will now reference, that useStaticMesh. So how do we do that? So we have this now, that is now set. We can do if, then we can do dot object is not a null pointer. Then we want to now go and assign that static mesh to our static mesh component. What static mesh component? Well, we created this chair component here. As soon as I start typing, you'll see something like set static mesh. I'll select that. You can see it takes in a useStaticMesh. Now the mesh asset is not actually what we want here. Remember that that is assigned. Again, if I go pick definition, you have here the object, and again we assign the template here the type of useStaticMesh. So this object is really the variable which is of type useStaticMesh, and this is going to be assigned, as I mentioned, or defined right here using these helpers. Okay, so what we want is mesh asset dot object. Cool. So I know this is a lot of weird stuff to take in if it's the first time doing this, so I'm trying to take my time here to try and make sense of this. So I have our chair component, which is a sub-object in our actor in the component hierarchy basically, and we want to assign a static mesh to that, not a skeletal mesh or something like that. We want specifically a static mesh. So we know that, and so we choose static mesh. If this assignment is successful, then we go and assign that. The succeeded here, unfortunately, these do not really have, this is not commented all that well, but this should also work. So if you do mesh asset dot succeeded, so in other words, if this assignment is valid and we have an assignment, the assignment to work basically, if that succeeds, then go and assign that to our chair component. Again, we are doing this in the constructor, okay, of the chair. So Control B to build that. Okay, so in the Unreal Editor, if I go to the level blueprint and I go and select chair instead of the chair blueprint, that will now again get spawned, and that should have our chair actor attached by default, as you can see. And we still go and apply that impulse that we set. So in begin play we have that add impulse, set lifespan, and so on. This works fine now because we now have that chair asset assigned by default. Then in the chair blueprint, if I now go and assign something else, maybe like one of these things, doesn't really matter what you assign to something else, you can see that we now have this revert button reset to default, and that will now actually revert to what we have set by default in C++, which is this sm_chair static mesh. If I drag those out, I now get one spawning from our custom level script, and I also have one that spawns because I dragged it into the world. So the problem with this is that that is hard-coded. Okay, so this is very hard-coded, but in some cases, as in this example, it makes sense to have it, because this adds this impulse to a static mesh component. So if I have this set up, but I don't have a static mesh assigned by default, then you could get problems like we've seen previously. So then you have to go and create a blueprint first, then assign your static mesh, and then it will work fine. But in this case, we are just making sure that we have an asset by default. We have a static mesh assigned by default, which makes sense for our particular class, in this case chair. And as you've seen, we can always go and change that later on. So if you have 10 different chairs and you have like a basic one assigned, then you can always go and change that in the blueprint if you want to do that. But again, this just allows us to have something by default if you want to do something like some physics, like add impulse and so on. So I hope that makes sense, and we can now move on to the next section. Okay, so I'm back in the test level script actor header file, and I'm actually going to remove this declaration here, the uClass myChair pointer. I'll just comment that out for right now. We'll use it again in just a bit. In the constructor, I'll go and remove this as well. I'll cut this part out, delete that, and then instead of myChair, what you can actually do, Ctrl V to paste that in, is you can, again, this static class will return an object of this type. So you can actually do it in this way. So let's say you do not want or care for the functionality to have that be specified in the blueprints by maybe the level designer or something like that, then you can always just go and specify it this way. And your actor is set up, the specific way that you want. It is ready to go basically. Then you can go and create an object in this way. Now before we build and compile this, there's one more thing I'd like to show you, and that is this getWorld. You can see it says again, will return null if the actor is not actually spawned in a level. So we can do a check for that. Once again, it is going to return a uWorld pointer. So what we can do, this here I can now actually initialize to this, okay? So this is going to return null if the actor is not actually spawned in a level. So we check for that. If myWorld is not null, a null pointer, then what do? We do that spawn actor. You can also, this should also work, so if you do this, if it's a null, then this will not enter. If this is not null, then this will be true, and then we'll enter and execute this. So as you go and refactor your code, it might be a good idea to go in and do these checks. And you can do them just like I showed you here. You see what that particular function call will return. Then maybe go and declare that as a variable and initialize it, and then go and do a check based on that. And we typically do this with pointers just to make sure that we are not using something that, that is a null pointer. So we check for that if something exists. So if that does actually point to something, then go and do something with that. So again, I probably will not go and do checks on everything as we go along through the rest of the course. I just wanted to show you how you can do this yourself. So let's just Ctrl F5 to build and run this and see if this works. Once again, we don't have any errors and we don't have any deprecated warnings. Okay, so back in the editor, actually I have to open the level blueprint again. This closes off each time. Then back in the class settings, I'm still inheriting from test level script actor. Class defaults, you can see that doesn't show up anymore. Don't really have any U properties exposed. In the header, I commented that out. So this is fine now. I'll just save all. And if I click play now, that still spawns. So I'll just delete these two blueprint instances. You can see I do not have a chair in my world outliner. As soon as I click play, I do have one that spawns from C++ basically. And it still has that static mesh applied and everything that we need. So again, I wanted to show you this because it's useful. So if it's set up properly the way you want, so in here, the object that you, or static mesh that you assign to your chair component, and you have everything set up the way you want. And now you can just go and spawn that where you want in C++. So again, just another option that you have available to you. So I kept this U property on purpose here. This is also a template. So the T subclass of is a template class that provides uClass type safety. So this is very useful for type safety. Type safety again is useful if you want to assign incompatible types to each other, and in that case you'll get an error. But more than just type safety, it is also very useful if you basically want to enforce the specific type that you want the designer to go and choose. So we have this chair class, and we want the designer in this case to go and always choose that particular class or something that derives from that, right? Again, this T subclass of allows us to basically enforce that choice. Previously you saw where we declared the U class. We had this long list in the details panel, so you can choose like a bunch of things, almost anything that is or can be a U class you can choose in there, but we want to narrow that down to our chair classes, and this is useful for that. So for right now, let's just go with a actor. We'll change this in a bit. Copy that. So basically what this is doing is we are now specifying or enforcing the rule that the designer in the details panel can now only choose actors or what derives from a actor. Okay, so I have this name here copied, and I'm just going to paste it in here. So we are going to spawn that actor that we then have selected. Okay, I'll build this. Okay, now in the level blueprint again, we have under test level script actor, unless again you give that a custom category, which I have not done in this case, you have chair to spawn, and once again we have this huge list. It's not as big as it was previously, if I remember correctly, but it's still quite a bunch of things. Now I can choose the chair, and then it'll basically go and spawn directly from the C++ class and instance one object from that. So let's just choose that and compile and save. I'll just close this chair blueprint class. You can see that works. And also you can do the blueprint, of course. What we can do is we can filter that down even further. So back in the header, let's do a chair now. It might not find that, so what you can do is up here, right underneath these includes and before the U class, what you can do is you can forward declare that class like that. That's just a forward declaration to basically tell the compiler, hey, this is not in here yet, but don't worry, I include it later. And we have included that in the .cpp file, which is fairly standard. If you look at other Unreal Engine examples and so on, you will find that this is the typical thing that you'll do. You see, this will succeed. You won't get any real errors. You'll just get a bunch of squigglies and stuff. That's because it's taking some time to catch up, but this will work fine. It compiles, so it will work. Now you can see in the level blueprints, in the class defaults again, you can only now select what derives from our chair class. So chair or chair blueprint. Play that and that works fine. So that is a quick demonstration of this T subclass of, and how to filter your options down in the details panel. This again is edit defaults only. There's actually a couple more things that I wanted to show you in this video, but it's getting a bit long. So what I want you to do at this point is to go and create a level script actor, and then try and spawn an instance of our chair class into the world, as we have done it in this video. You can use the T subclass of. In the beginning of the lesson, I just showed you the U class, okay, that declaration, just to show you the options that you have and how it works, and then eventually why you would use the T subclass of instead. So go and do that first, okay, try and get that chair component to spawn. It doesn't have to do all of the add impulse and the destroy and everything. The important part here is just to get it to spawn. Once you have that working, the next thing is to go and create a C++ class deriving from game mode. So we're going to create a custom game mode now. Then you are going to set your custom game mode in world settings or in your project settings. Then what you want to do is you want to again go and spawn an instance of our aChair class into the world, similar to how we did it in this video. But again, you have to actually make sure to set the game mode. So try and do that. You can just call it my game mode or something like that, just as an exercise, and in the next video I'll come back and I'll show you how to do that. It's basically just going to be a copy and paste in some instances from what we have already, and there's a few other things that I'd like to then show you once you are done with that. I know we have introduced a lot of new topics and templates and stuff like that, and it can get a bit overwhelming at first, but even if you have to watch the video a couple of times, that's fine. You have to practice these things, do it a couple of times, look at the parameters, look at what you can feed into things, look at what you can return from certain functions, and take your time, and eventually it will become easier, okay? So with repetition. So again, I hope you find this lecture useful, and I'll see you in the next video.